Hello, this is Femi Ola, reporting live from the Web3Bridge house. Anyway, so we are currently in our fifth week here, and we've taught a lot. I just want to quickly go through the things we've been taught. So we built a contract. We've been delving into smart contracts. So far, we built like a vault for where you can, you know, for grants. Maybe you can store money in that vault, for example. That's one of the use cases. Like grants funds for someone, and the person can later come and withdraw it. Maybe uh, you can set a time frame for when the person can withdraw it, and you can also control the amount. Also, one of the things we've done, one of the interesting things, is to create a token. Like the Shiba Inus and safe moons of this world, something like that. And so I'm going to go through a code, you know, which is an extract of something we actually did in class, but I have removed a few things to make it shorter and for the purpose of this video. And yeah, so I'll just go through the code explaining what it does and just to demonstrate some of the things I've learned. Anyway, so this is it. Energy 1. So it's a spin-off of the original energy contracts. And first line is all about the regular boilerplate things, talking about the license, talking about the solidity version for our compiler to understand. Let me enter to full screen. So moving on, these are some of the things we want our contract to have. So this is not standard because I got to learn just this morning that according to standard definition of what a token contract should have, um, there are some other functions that are necessary, such as the approve function. But for the purpose of this video, we are just going to go through this for the sake of brevity. So we are using the constant, we are defining our variables here as two variables. We are using the constant keyword because we are sure that these variables are going to be constant throughout our contracts. So I don't know if any other advantage of using that constant keyword. I guess there could be some gas saving property related to that. Anyway, moving on. So this mapping helps us capture um, a relationship between the address of a user and the person's balance. Okay, and in this constructor, we are capturing the address of the person of the deployer of this contract, the first person to interact with this contract. And later you are going to see our mint function, and I decided to mint immediately the contract is deployed. You see our mint function later. So this function simply just allows our user to say the name of our contract. This one allows our user to say the symbol of our contract. This one allows our user to see the total supply. And this is our mint function. So in the first line, we are ensuring that only the owner can mint. Okay? And that happens when the constructor is triggered, the first interaction with the contract. Then on the second line, we are, once minting is done, we are increasing the circulating supply. I want to ensure that circulating supply that we have is less than or equal to total supply. It must not exceed this total supply. And we are minting into this contract address. So this next function is the transfer function. This is the function that allows someone to transfer to another person. Okay. On this first line, we want to ensure that the users don't lose their funds by transferring to the dead address, which is address 0 in Ethereum. And we are updating our users balance. On this one, we are ensuring that the balance of the user is okay. On this one, we are capturing our user's balance, the balance of the person trying to send energy tokens to someone else. We are capturing the balance, and we are ensuring that the balance is not less than the amount the person is trying to send. And on this line, we are going to actually deduct the balance from the person's account, and then we are going to send the balance here to whoever the recipients. So this function enables our contract deployer to be able to give tokens out, send tokens out, right? So we will ensure that the balance in this contract is not less than the amount the person is trying to send out. We reduce the balance in this contract, and then we send the balance to the recipient. This is the function that helps. Helps people check their balance. So it returns the balance of whatever address is sent into it. So let's try to deploy and test our contracts. Let me just copy that code. And so deployer, compiler, remix ID. So we are going to deploy. So let's check the balance of let's check the balance in these contracts. Let's see what it is. So we have 10,000 energy tokens in this contract. So let's disperse some tokens to this company. Let's say I want to disperse just 1,000 tokens. Yeah, I send and it's here. The transaction is successful. Go and check back. So let us transfer from this person okay. So we are going to allow this person transfer to someone else. We are going to copy this other contract. So this was the person we dispersed to. So we are going to allow this person we dispersed to transfer to this person. This new contract. So let's transfer just 500. Transacts. And you can see underneath again that we got no error, so it was successful. So let's check the balance of this contract. This new contract and transfer to balance of, you can see here that's 500. So we were able to successfully send 500 energy tokens. So what's the name of our token? Energy, our symbol, ENG, our total supply, 10,000. Our circulating supply, 10,000. Yeah. So that is just a simple contract that demonstrates what we've learned so far at the Web3Bridge Cohort 7 blockchain development bootcamp. Thank you.